Hi guys, welcome back. I'm Amit from Networkers Home Technical Team. So I'm going to be start one TCP series. So in TCP series, we will discuss all the TCP topics here. Okay. So this is a kind of end-to-end program of TCP here. So let's start. So this is the TCP syllabus here, which we are going to be covered in the upcoming series here. So I have divided the syllabus into the different sections. So the first section is your section A, so which is about introduction to TCP. So this section actually I'm going to be covering today after this slide. So in this section, we will discuss what exactly TCP is, why we need TCP, and what are the objectives of the TCPs there. So this is I'm going to be discussed into the section A here. The second is section B. So what is the section B exactly? So in section B, we will discuss TCP connection establishment and termination here. So how TCP connection would be established, how it would be terminate, what exactly the three-way handshake process, what exactly the four-way handshake process and all. So those things we will discuss into section B here. So this is the first point of the section B. Second point is TCP options here. So guys, as you know, TCP options is one of the very important term in the TCP here. Okay. So actually in TCP options, if I'll talk about MSS will be there, okay, selective acknowledgments will be there, timestamp will be there. So like there is a different options which I'll cover in TCP option here. So on these topics, guys, I will make one videos. Okay, so I'll show you the theoretical as well, and along with that, practical also. Next topic in the section B would be advanced mechanisms. What are the TCP advanced mechanisms? How actually we use that? Reset segments there. Okay, what exactly the meaning of reset here, and what are the exact reset segments and how we have to use it here. Attacks involving TCP connection management. So TCP connection management means when we establish the connection and when we terminate the connections there. So during the connection establishment and the termination, is there any possibility for the attacks? And if yes, so what kind of attacks there, and how to protect our TCP connection from these kind of attacks here. So all these terms we are going to be discussing in the section B here. So the next is section C. So in section C, the important concept is TCP retransmission overview. So what exactly the TCP retransmission overview? Then retransmission timeout. What are the meaning of the timeout? How to use it? Then time-based retransmissions there, fast retransmission process, selective acknowledgement and retransmission, spurious timeout and D as selective acknowledgement, then packet recording, duplication in the repacketizations, and in the end there would be packet involving attacks involving TCP retransmission. Means during retransmission, TCP retransmission, so is there any possibility again for the attacks? If yes, so what are those possibilities there and how to protect from the attacks here? So this attack is about for the TCP connection management, and this attacks I'm talking about here during the retransmission. I hope this is clear. So these are the two different attacks concept here. Okay, let's move to the next section here. The next section is section D. So the section D is all about delayed acknowledgements here. Okay, so what exactly the delayed acknowledgement? Nagel algorithms and the Clark solutions. So what exactly is the Nagel algorithm? How it will help us? Okay, so where to use it? So we will discuss about Nagel algorithm also in. So it's very important from the interview perspective. Sliding window, one of the very interesting topic. Okay, and from interview perspective, this is very important. Then zero windows and attacks involving in window management. So this time, guys, attack is again there, but this time this is in the Windows management. So three attacks I have mentioned. The one is attack which is with the connection management. Second attack is which is related with the retransmission, and this attack is about the Windows management here. So all are the different attacks here. Okay. The next section is E. So section E is what? Congestion control. Again, one of the important concept for the interview perspective here. The congestion control, what is the slow start and the congestion avoidance? Slow start is one of the congestion control mechanism. Okay, so how to avoid the congestion control or congestion actually in the TCP network here? So there would be some avoidance, there would be some how to avoid the congestion, and for that there is some mechanisms which we have to use it, and slow start is one of the mechanism which we used for the congestion avoidance. Congestion controls using selective acknowledgement and F acknowledgement here, then buffer bloat and ECN, and then again here attacks, but this is involving congestion control here. So live attacks we will try to capture there, okay, and we will see how to protect from the attacks there. The next and the last session is TCP keep alive. Again, most important topic from the interview perspective. Then keep alive process, how exactly keep alive messages would be there, and then keep alive states. Okay, so this is the section which is related with the keep alive here. So I have divided overall TCP syllabus into different sections. Okay, this is for introduction, then it's about the connection management here. So this is the connection management related, and this is the retransmission related, this is the Windows management related, this is about the congestion control, and this is about the keep alive states. Okay guys, so these are the things which we are going to be covering. So in today's videos, I'm going to be start here with the section A. So now we will discuss what is TCP, where to use, what are the TCP objective. So this would be our first section here guys. Okay, so let's start with the same. Okay guys, so now what is TCP? Okay, so as you know, TCP, I hope everybody knows OSI model, right? In OSI we have 7 layers. So TCP is your layer 4 protocol, right? So layer 4 usually there we have UDP also, which is again second most usable protocol here, but in this series we will just talk about the TCP. So after the TCP I'll record one series for the UDP, and there only we will compare TCP versus UDP there. So let's start about the TCP here. Sorry. Okay, so let's start with this. So TCP, so transmission control protocol, which we use on layer 4 exactly. Okay, so this is as per the OSI layer, this is the layer 4, and the protocol number is, I hope everybody knows, that is protocol number 6 here. So transmission control protocol is a communication standard that enable application program and computing devices to exchange message over a network here. So let's consider there's a site A or site B, or there's a client or server. They're connected over the internet. So how they will communicate over that? Let's consider this is client and this is internet here, and this is the one server. So let's consider if I talk about this is the Facebook server. So how this client will connect with the Facebook server, how they will exchange the exactly data is, okay, that for that we need TCP protocol. So TCP is one of the reliable connection establishment. So there are some objectives that I have already mentioned in the next slide here. Okay, so TCP in short, in the simple language if you want to learn, TCP is kind of one of the transport protocol. Let's consider you have to travel from Bangalore to Delhi. You will travel, you have an option, okay, I'll go via air, okay, second you will go via your private vehicle, third option you have via train. So we have different mediums here. Depends then which medium is secure, which is a bit expensive. If I talk about, let's consider myself, I want to travel from Bangalore to Delhi. I have first option train, but somewhere I'll think, oh, okay, train is not secure. Second thing might be it will take too much time for me. Okay, it will take approximately 40 hours there. So in the term of saving the time and in security, might be I'll choose which one? I'll choose the by air. Okay, because via air it will take only 3 hours, which is most secure. So based on the requirements, Okay, based on the security, I'll choose the transport medium from Bangalore to Delhi. So same here, from one client, okay, or you can say from one computing device to another computing device, if you have to exchange any data, okay, so for that we have to use TCP, or we can use TCP, but that depends on the TCP features there. Even we have option for the UDP, but why TCP? That we will discuss in the upcoming classes here. Okay guys, so this is about TCP. So TCP organizes data so that can be transmitted over and a client here. Like this is you are connected with internet and you want to access Facebook from here. Okay, so between you are acting as a client here, and this is a server. So between both the clients and server, if you want to exchange the data, for that we need TCP. It guarantees the integrity of the data here. What exactly the meaning of integrity? Integrity means when we are exchanging the data between both the sides. So as a sender or as a receiver, okay, I want to be sure that when we are exchanging the data, or when I'm receiving or when I'm sending the data, that should not be modified by any third person in between. Okay, let's consider attacker is also what? He is also connected with the internet here. So when I'll exchange the data between server, so I want to be sure, okay, that the data should not be modified by the third person here. So this concept is known as integrity of the data. One simple example. I've ordered something from the Amazon, okay, and this is your parcel, okay. Let's consider if this parcel is already opened by that delivery boy. So guys, seriously now just tell me, okay, you are going to be accepted? Definitely not, because here integrity of package is on stake, okay. So same here, when we exchange the data between client and server, we need integrity of the data, and TCP provides us that integrity. How it will provide, we'll discuss in the upcoming videos. So it guarantees the integrity of the data being communicating on the network actually. So before it transmit the data, TCP establish a connection. As you know, TCP always use three-way handshake process. Okay, the concept for establishing the connection, or even in establishing the connection, TCP use four-way handshake also. Yes, correct. Okay. Yeah, it's not only three, it's used four also, four-way handshake process. Okay. So we'll talk about that. Okay. TCP connection between source and its destination, which ensure remains live until communication begins there. You want to travel somewhere along with your friend. Okay. So let's consider you want to make a plan. So first of all, you will confirm with him. Okay, let's go to this place, let's go to this place. So then only you can proceed with the plan. Okay, let's consider without informing your friend, and if you will make a plan and if you will book the tickets, and in the end, if your friend will deny that thing, so then that is about the loss here. So same between client and server, if you want to exchange any data, so first of all, you have to establish the connection. And for that, we have three-way handshake process for same, and then we have four-way handshake as well. Okay, so those things we will discuss in the upcoming session, because this is just the first session only. This is just an introduction. Okay, so this is the reason very basic things are over here. So guys, I hope this is clear to everyone. So this is all about the TCP. Okay. Now, these are the TCP objectives which I'm going to be discussed now. So the first thing is reliable data delivery. What is the meaning of the reliable data delivery? Data integrity, guys. I hope just 5 minutes back I was talking about the data integrity. So same data integrity is there, and this is the one of the important objective of the TCP here. Order data delivery, okay. Flow control, congestion control, connection establishment and termination, then error handling, and end-to-end communication. So these are the objectives of TCP, guys. Okay, so in this video I'll just give you the theoretical idea about that. Okay, but in the upcoming videos, one by one, we will talk about all these objectives there, how to achieve these objectives, means how TCP use or achieve these objectives, and how it will provide us the security over the internet here. Okay, so first of all, now I'm going to start with the reliable data transmission. Now, the first point here, reliable data transmission. Okay, let's talk about it. So TCP ensures that the data sent from the one device is reliable, received by the destination device here. So in TCP, guys, we have concept about like acknowledgement. Okay, so when a device will transmit the data to the another device here, this is the data, so the destination device would send one acknowledgement there. Okay, so that concept is like in the term of what? Reliable data transmission. It accomplishes this through mechanism such as acknowledgments there, guys. Okay, so this is the same point again here. So how TCP will achieve this objective, which is the reliable transmission, that would be there with the help of your acknowledgments and retransmissions. Okay, so in interview, if someone will ask you, okay, do you know what is the like TCP reliable data transmission? So might be, okay, instead of the directly asking about the acknowledgement or retransmission, they will ask you like indirect way. So in the indirect way, they will ask, what do you know, like, does TCP support any reliable data transmission here? Okay, so when the data is sent, the sender waits the acknowledgement from the receiver. If acknowledgement is not received within a certain time frame, then sender retransmit the data here. Okay, so this is the concept about your reliable data transmission. Second thing here, again, integrity. So the TCP check the integrity of the data by using checksum. Hope you've heard about the checksum here. So it would be there with the help of some hash functions. Okay, so TCP will perform some hash function and will find what? And will find one checksum value here. Let's consider this is the data. On this data, TCP will perform some hash functions, and after that, there would be one checksum value here. Okay, so this checksum value will help us, okay, for in the form of data integrity here. Okay, so the sender computer checksum of the data, it sends and check the checksum to the verify that data was received correctly here. And if there is a mismatch, the receiver requests for the data to retransmit the data here. Means, in short, this is the one parcel you have ordered from the Amazon. Amazon is sending it to you. And this is the one of the delivery boy. Okay, so delivery boy will carry your parcel and it will finally reach destination, which is at home. This is you here. Okay, so what happened if data or if your parcel is already opened, okay, via this delivery boy? So what happened there, guys? Obviously, the data means the parcel has been already opened and you are not going to be accepted. So same way, when between client and server, you are exchanging the data with the help of TCP protocol. Okay, so data integrity would be there. That TCP will provide you the by default. So in case between client and server, if data has been modified by any hacker or attacker, so then receiver side will not accept that data, and that would be happen with the what? Checksum value here. In details, we will talk about the checksum value also. Okay, so this is, guys, the objective, okay, of the TCP. Next is order data delivery here. So TCP ensured that the data is delivered in the same order it was sent here, and this crucial of the application that sequential data here. So which concept we are going to be used here into, like usually we use sequence number. So sequence number is one of the term, okay, or you can say one of the mechanism which help us to achieve order data delivery in TCP. So usually guys, UDP doesn't support any sequence number, but TCP does, and based on that mechanism, TCP provide what? Order data delivery here. Okay. I hope all these points are clear, right? Now, the next is flow control. So what exactly the flow control objective is? So TCP include flow control mechanism to prevent a faster sender. Means, consider, for example, okay, just better example I'll give you, okay. Let's consider, this is your trainer and this is you, and your trainer is delivering the lecture, okay, and he's delivering the lecture so fast, okay, and it's been almost 3 hours continuously he is just delivering the lecture. But obviously you have some limited things, okay, you have also limit here. Might be after 1 hour you would be exhausted, and after that whatever you were, that would be kind of bouncer for you. I mean, that is the data drop here. So same in the term of the network also, if you have 2 devices and one device is sending the data at 1 Gbps speed here, but another device is processing with the same data at the speed of 100 Mbps only. Okay, so this device is receiving the data at the speed of 1 Gbps, but further it's processing at the speed of 100 Mbps only. Okay, so this concept is known as flow control. So what would be there after some time? Obviously on this device, then its buffer would be full, because further processing is happening at 100 Mbps, and in the behind we are receiving the data at the 1 Gbps here. So after some time the buffer would be full and the data starts getting dropped there. So this concept is about flow control. So how TCP would like deal with this? So TCP include the flow control mechanism, prevent a fast sender from overwhelming slower receiver. So sender would be the faster and the receiver would be the slower. So the receiver signal the sender to slow down. So then receiver will send a signal to the sender to slow down if its buffer is filling up. So thus preventing data loss due to overflow. Okay. So this is the concept which we have in TCP. Very important interview perspective. Okay. Now, okay. Congestion control here. So TCP help manage network congestion by dynamically adjusting its sending rate based on the perceived state of the network here. Let's consider traffic jam. I hope you heard about the traffic jam. So same guys, when over the internet we are exchanging the data, okay, with the servers. So in that scenario also there is a traffic jam, and that traffic jam concept is known as congestion actually. And how you will deal with the traffic jam? That mechanism is known as congestion control. I hope this is, it's very simple. Okay, what is exactly the congestion? So in the real network, if a real example I'll give you, so congestion is equals to traffic. Okay, traffic jam exactly. So traffic jam, how you avoid with that? Okay, so like for that there's a different options are there. So same in the network, when congestion would happen, how to control that congestion. That mechanism is known as congestion control, and TCP provide congestion control mechanisms to us. Okay. So the next is, so this is about connection establishment and termination. So as you know, when we use TCP, so TCP first of all always use connection establishment. So there is we have 3-way and four-way handshake concept we have. Okay, and after that there would be data transfer. Okay, and after that there would be connection termination here. So this is known as termination. Okay, so this concept is supported by only TCP. Okay, so TCP support, guys, your connection termination and connection establishment and termination mechanism here. Next is, and even I have mentioned here, this is achieved through a three-way handshake for the connection establishment and the four-way handshake for the connection termination. Okay. The next is error handling. So what exactly the error handling? TCP provide error detection and the recovery mechanism by default here. Even if I talk about any other protocol, look, they are not providing any kind of error handling concept, but TCP does. So if packets are lost or arrived out of delivery, okay, even in the objectives we have seen there was an option about out of the order of delivery, So same concept is here. So TCP takes corrective action to ensure complete the correct data transmission. Means, for example, sender, you are sending the data like 1, 2, 3, 4. You have 4 packets which you have to transmit. On the another side, you have transmitted all the 4 packets, but on the other side, this side has just received first and fourth packet. So what about the third and? In case if delivery of the packet is out of order, so how it will assemble it? So that concept is again provided by the TCP only with the help of the sequence number. Okay. So in error handling again, TCP use sequence number concept also. Okay. And the last objective is end-to-end communication. So TCP facilitate communication between process which is running on the different devices here. Okay. And it abstract the complexities of network communication, okay, which is allowing the application to focus on their specific task. Okay, guys. So this is the last concept here, which is about the end-to-end communication. Okay. So guys, we are completed with. So this is about the TCP. So in this video, we have discussed about the TCP syllabus, and along with that, we have discussed all the TCP sections. Okay, what exactly the syllabus is. And in this video, guys, I have completed section A, so which is basics of TCP. So in the upcoming videos, we will start with the section B, which is the connection establishment. Okay. So guys, thank you for watching the video. Thank you.